Yeah, welcome everybody. This is a special episode where I will be the host. I'll be presenting and the topic of my talk today is mastering AI art generation using using stable diffusion. Now, with me is Phil Nelson, who is the director of content and creative at OpenCV. For this episode, usually if anything goes wrong, it is Phil's fault. But for this episode, because I'm the one presenting everything, if anything goes wrong, it's my fault. We'll have to, sometimes I have to take some blame.
He's humble too, folks. What a guy. Yes, it is me once again, the co-host with the co-most, the second banana who is second to none. I am also your plus one and only. It's Mr. Nelson if you're nasty, but you can call me Phil. This episode of OpenCV Weekly Webinar is indeed a special one, but we're doing the same thing we do every single week. One of those things is give away something to you in the audience. Later on in the episode, we will do a trivia question. The winner of that trivia question will get a free license to this upcoming course when it releases, which, what's the stated release date for this new course, Satya?
Vikas, correct me if I'm wrong, it is May 1st, right?
Yeah, it's May 1st.
Excellent, excellent. We're also taking questions and answers. So we're taking questions from you in the audience, which we will hopefully provide answers for. Use the little Q&A button at the bottom of your Zoom window to ask questions anytime during the show, or use the chat system wherever you're watching, Twitter, Twitch, Facebook, etc., etc. And we will do our best to flow it into conversation. In case you didn't know, this webinar is sponsored by OpenCV.ai Consulting, a computer vision consultancy that includes our esteemed hosts, Dr. Satya Mallick, Anna Petrovicheva, Gary Bradsky, real luminaries of the computer vision field, and they can consult on your project. Go to OpenCV.ai to contact them. Satya?
That's great. And also accompanying me is Vikas Gupta. He is the course director at OpenCV.org. So much of the material, what goes into the course, he manages all the aspects of our course team. So he's the boss of our course team. Hello, Vikas.
Hi, Satya. Thanks for the introduction. And hello, everybody. It's so nice to have all of you here. Welcome to the webinar.
Yeah, welcome back. We were talking before the show. I think it's been like 60 or 70 episodes since the last time you were on here. So welcome back.
Yeah, I'm hoping to be more active from now on.
You got a long way to go to catch up with Joseph.
All right.
Yeah.
Okay, so let's get started. Let me share my screen. All right, so so mastering AI art generation. If I have some typos, etc., in this presentation, I apologize in advance because this is a really fresh set of slides. Now,
much like the technology, these slides are in early days.
Much like the technology. So most of the technology that it's literally, let's say, less than a year old. April 2020 was when Dali 2 was released, and Stable Diffusion, which is the open source version, was released, I think, in August 2022. So we are literally, this is the cutting edge of things. But the most important thing here is that we have been able to use cutting edge stuff in our consulting services. Usually, it takes about a year, 2 years for technology to be mature enough when we start seeing research papers. From there to actually using in our consulting services, it's usually, easily 2 years, right? But this one is so breathtaking. It is so astounding that we are using these techniques in our consulting services today, right? That is why we decided that, look, this thing is moving so fast. We have to create a course which does justice to this emerging field. And it's amazing how fast things are moving. So let's get started. Now, all these images here that you're looking at were generated by AI. None of them is real. And these were all generated for one of our contests. So we, just before we launched the Kickstarter campaign, we did a little contest about people talking, the idea was that they would create an image where they talk about three things: love, because we launched it on Valentine's Day. The second was science and art, right? So people created these beautiful, beautiful images using that theme. And, you can see that middle image is Madame Curie and Pierre Curie for doing some experiments in the lab. The first prize winner is a little boy, talking to a dog. And you can see that the dog has a bit of a robotic component to it. So beautiful imagery here. And all of this.
Talk about leaving it all on the field with the Curies, huh?
Yeah. Because I was not one of the judges in this competition, this image actually was not selected, but it is, I really loved this image. But anyways, I was not one of the judges. So I included it in my presentation. And then there is the side image also, beautiful art. The most important thing about these things is that it has been created by writing text, right? You write a few lines of text, and this image is generated for you. You don't use any paintbrush, you don't use anything, you just write text. Literally on your keyboard, you write something like 20 words, 30 words, and these images would pop up, right? Amazing. So this is something that is pretty new, right? It is also combining natural language processing and computer vision. So that's the beauty of these techniques, right? So let's go. So I'll skip my introduction. I'm the CEO of OpenCV.org for people who would be watching it on YouTube later on. So this is just a quick introduction. Now, the talk outline, I'm going to talk about what is generative AI. Then I'm going to talk about generative models in computer vision. We'll talk about applications of one generative model called Stable Diffusion, because it is open source and a lot of people are building applications on top of Stable Diffusion. And finally, I will talk about our Kickstarter campaign. So now, what is generative AI? Generative AI involves using algorithms and neural networks to generate new content, such as images, videos, music, and text that is similar or inspired by existing content. Now, the interesting thing about this definition is that I generated it using ChatGPT, which is a generative AI model, right? These are not my words. So think how powerful it is, right? It is able to create this very well-formed sentence, which was not possible. Frankly, it was not possible 6 months back. This would be science fiction just 6 months back, creating this nice text, which is grammatically correct, it is all consistent, and it is right. Now, the current version of ChatGPT and all the NLP models, they are not 100% accurate. They are making a lot of mistakes, but this is the tip of the iceberg, right?
Also apparently threatening people.
Yeah, this is like, when Apple Maps was released, right? People used to land in the middle of deserts. Right?
Yeah, you can't just follow the GPS. You do have to look around you.
Right.
That's definitely an issue. I used to play with Markov chains a lot when I was a teenager.
Yeah.
And you would get these cool, interesting sentences that, as a friend of mine, Steen, who's a writer, said, it wrote sentences that coiled around themselves like snakes. I think that you sometimes get that with ChatGPT and like the Bing stuff, but it seems it bullshits better. It gives the facade of being a person better.
So there is this competition between Microsoft and Google now, right? The CEO of Microsoft is Satya Nadella. The word Satya actually means truth. And the CEO of Google is Sundar Pichai. The word Sundar means beautiful. And I like to say that, ChatGPT kind of this large language models are Sundar, which means they're beautiful, but not yet Satya, which is they are not yet true, right? So
what is truth if not beauty, and beauty truth, as they would say,
right? Or as the lawyers sometimes like to say that this statement has the additional benefit of being true as well.
Yeah, it's nice when that happens.
Right. So, but you have to you have to keep in mind that this is the tip of the iceberg. We are just getting into these things, and they are not 100% accurate. It will take them a long time to be accurate, because the last, whatever 20-30% will take a very long time to fix. But you can still do a lot of things with these things, even without 100% accuracy. Don't try to write, take them as a source of truth, but there is still a lot that can be done, right? So what is generative AI, right? One, like we said, that it is basically creating new content, which it could be text, it could be music, it could be images or videos, by training a model on existing material, right? So ChatGPT is an example. You can ask it questions, you can expand your summarized thoughts, you can convert code. And this is funny that we actually we have used ChatGPT to convert our Python code to C++, and pretty much it nails it very well, right? It's not going to nail it every time, but 80%, even if it writes 80% of the code for you, that's making you 2x, 10x more productive, right? And you may be thinking that, oh, this is for people who are not experts, but I'll show you some examples. So the other one is Stable Diffusion, which is in computer vision, and this is what we are very interested in. It uses it generates.
Quick note, Satya, your mouse cursor is on the text there. You might want to slide it. There we go.
Okay. So Stable Diffusion, it generates image using text, and it can also be used to edit images that are guided by text or other images, right? And we can also create animations using this. So now, why do you want to learn generative AI, right? This whole, and I'm the messenger. Don't hate me for saying this. I'm the messenger. I'm just delivering you the bad news or good news, depending on who you are, right? So for creativity, there used to be two essential ingredients. The first thing is that you needed imagination. Let's say you want to paint something. You needed the imagination to figure out what you want to paint, right? So like if you want to create Starry Nights, then you need to have that imagination that I'm going to create that painting Starry Nights or the Mona Lisa. Then the second thing is that you needed the skills to do this work, right? Now, unfortunately or fortunately, depending on who you are, skill is not as important, or in the future, the skill will not be as important. There will always be a very large, group of people who would use both skill and imagination, but there will be a much larger group of people who can use their imagination without much skill to actually finish work. Now, I'll give you an example, right? We may think that, oh, this is not a good thing, but I'll give you an example. There was a time when people used to transfer knowledge by memorizing, right? So one group of people, because there was no text, there were no books, so you had to transfer knowledge from one person to another, by one person telling the other person all the information they had, and the other person had to memorize and keep them in their mind, right? So that is a real skill, to have this whole body of knowledge in your head. But then books came along, and you could argue that, oh, books are, they do not require skill. You can just go and look up things instead of having the skill of memorizing a large amount of knowledge, right? But what books did was they democratized this knowledge, right? So there are still people, maybe not now, but books expanded our ability to do things, right? So we lost the skill of memorizing that, most people don't have that memorization skill now, but books did help advance humanity. But there is also this ethical issue here, that we are learning all these language models, and large models have learned on the work of artists and other people, and how do you compensate them? That's an open question, and over the next few years, I'm pretty certain that there will be a way to make it more fair to people who are involved. But regardless of that, the fact that you do not need as much skill to create a work of art, create a piece of text, it is not necessarily a bad thing, right? Just imagine I'll give you another example, Jan LeCun, right, who is French. He is one of the godfathers of deep learning, right? So he's a Turing Award winner. Now he's French. To write his papers in English, he had to struggle a lot, right? So one of the things that he thought about, that these language models that will help people write beautiful papers, which the other people did not agree with him. But from his point of view, if he had this tool which could write a paper for him, he could just summarize the paper, summarize his ideas, and it created the text for his paper, that would be a huge benefit for somebody who did not know English or did not know English very well at that time, right? So yeah, something to ponder about. You may not agree with me completely, but I feel that it's not a negative that you do not need as much skill, but you still need the imagination, right?
Sure. To chime in a bit, we do have to be conscious of and thoughtful about who exactly benefits from these changes and what skills are necessary. And yeah, we have to be very careful, because it's very easy for things like this to just become yet another power transfer to the Googles, Facebooks, Microsofts right. of the world, away from regular people. Yeah. And that is, I think I don't need to say it, but I will anyway, very bad when that happens.
No, I mean, there are no easy answers, right? There will be regulations, there would be, so there are, troubled waters ahead, and we don't know how things will move. But we cannot be left behind when such transformations are happening. We have to be aware. We need to understand how they work and things like that, so that we can even participate in the conversation, right? So
and there are many benefits to be had broadly, like writing the paper, for example. That's sort of this perfunctory, almost like bullshit part of your job, right? Like you've already done all the actual work, and now you have to summarize it in a way that people who read papers for a living will like. And so, of course, have the machine do that. Like, why wouldn't you? The important work has already happened. So yeah, I mean, it's the ethical questions are important ones, but that doesn't mean that there aren't benefits to be had.
Yep. So there's another one called Copilot, GitHub Copilot. And I used to think that, the people who are just learning a new language or things like that, they are using Copilot. But I know two very good programmers, including Andres Karpathy, who are using Copilot, right? So you can see here that he's saying that he writes 80% of the code and he's just editing, he prompts and he edits the code. For somebody like Karpathy to say this, for people who do not know, until recently, he was the head of AI at Tesla. So he's a really big deal, right? So he's using Copilot, and you can imagine that these things are not just for beginners or people who do not know programming. People who know programming, they can 10x their skills using generative AI. Now, let's understand some generative models. What are generative models, right? Now, if you have taken any course in computer vision, especially image classification, you may have come across this thing called discriminative model. Let's say you have two classes, the red dots represent cats and the blue dots represent dogs, right? A discriminative model, let's say you are training a classifier which is based on a discriminative model. It tries to find the line that divides, or it could be any shape, but let's say for simplicity, the line that divides the two classes, right? So we divide the cats and dogs, and once a new image comes in, we project it onto the space, and based on which side of the line the point lies, we are able to classify it as a cat or a dog, right? Now, in discriminative models, the model doesn't learn anything about what is the appearance of a cat or a dog, right? It just knows the boundary between these two classes, right? It separates the two classes, but it doesn't fundamentally know what these classes look like, right? In fact, it doesn't even care to draw that line. It doesn't even care about things which are far away from the boundary. Let's say things which are far away from the boundary, it doesn't even care about those. It's mostly concerned about things which are close to the boundary. On the other hand, there is another way of solving this problem where it is called a generative model. A generative model takes all the samples and tries to build a model of data. So it tries to understand what a cat or a dog looks like, not just what is the differences between them. Does that make sense? That you're not just learning what are the differences between them, you're also learning what does a picture of a dog look like, right? So it is able to regenerate. So if you pass this noise through a neural network, you will be able to get a sample of this dog or a cat, depending on which class you're trying to measure. So it understands by generating the data. It has the capability to generate data which will look like a sample from this distribution, right? So these are the two methods of solving problems in AI, even classification problems. But for simple things like classification, discriminative models are very popular because they are very simple and they do a very good job. Now, what does generative model look like in case of an image? So usually what these generative models do they start with noise and they create a sample of the distribution that it was trained on. In this case, for example, the owl image you are seeing, you start with noise and then you run it through this noise through the neural network, and it will generate a sample of the image which is from the owl distribution, right? All the owls that it has seen, it will generate an owl. So what are the various types of generative models? There are 4 or 5 different kinds of popular models. The first one is variational encoder, flow-based models. But the most popular ones these days are generative adversarial networks, or GANs, and diffusion models. And this diffusion models, it's a pretty recent trend. Literally less than a year back, these things started becoming very popular. Although the first diffusion model, the ideas were there since 2015, but really they have become popular in the last few months. Now, let's talk a little bit about GANs. So GANs are used to be very popular. They're still very popular. They are based, the idea of a GAN is that there are 2 models that you're training simultaneously. So inside this GAN architecture, there's this generative model, which we can call a student. And the idea of this generative model is to capture the distribution of the training set, right? It wants to, we'll see using an example. So it is a student, and the second one is is a discriminative model, which is a teacher. And the student keeps generating this. Let me give you an example so that it becomes very clear. So here, starting with noise, the generator's job is to generate an image, and then it asks the discriminator, does it actually look like a fish, right? Here we are trying to generate an image of a fish. The discriminator says, no, it doesn't look like a fish, do better, right? So the generator goes and tries, modifies its weights, etc., and tries to learn what a fish looks like. And iteratively, it actually generates the image, right? So here is an example. You start with random noise, you pass it through the generator, and the generator tries to create an image. And the job of the discriminator is to look at that image and say whether it is actually real or fake, right? Whether it is from that distribution or not, right? And so there is this tension between the student and the teacher, right? The student is trying to generate an image and say that, oh, do you think this is a real image from the distribution it was trained on? And the distribution in this case could be, different scenes of different buildings, etc., right? And the job of the discriminator is to say, whether it is true or false, right? Whether it is actually, what is the probability that this image is fake versus real. And when you keep this training, right, they are basically, that's why the word adversarial comes into play, right? That's why the name has generative adversarial network. So because one is trying to generate, one is trying to fool you, the other is trying to predict whether you're being fooled or not, right? And so they are simultaneously trained, and things get better and better, right? That's the main idea behind GANs. One of the most popular examples of GANs was this this website, This Person Does Not Exist. You can go to it right now and it will show you an image. And these people do not exist, right? These examples that you shows. So basically, this GAN was trained on many, many images of humans. And now, starting with noise, every time you go to the website, refresh the page, it starts with a noise, and then it generates a sample of a human, because it was trained on human faces. So it can generate a sample of a human face. But this face does not exist, right? It looks like a human. It looks like somebody, somebody's picture, but this was not part of the training set. It hallucinates these images from noise, right? So very powerful.
Yeah, one of the things you see with like This Person Did Not Exist in terms of the progression over time is it used to have a lot more screw ups with like teeth and the edges of people's hair and stuff.
Yeah.
And teeth and fingers are still, a lot of people have made this point on Twitter and other social media that it's sort of like we're regressing back to the days of the old European folklore monsters, that make sure you count the number of teeth and fingers they have, because it could be some kind of fey creature trying to trick you into a deal, Yeah.
Another common mistake it used to make is earrings, right? It would have different kinds of earrings in the 2 ears.
Yeah.
Those were some mistakes. Now, GANs, they just don't need to be, you can also guide the GANs. For example, there is this pix-to-pix GAN where instead of starting, you still start with noise, but you guide it. You can give a picture as a guide and it will generate another picture. So in this case, for example, you're giving it an edge image and it will generate a plausible output image, and it's basically image to image guidance. You could also give it an input map like this. I don't know whether it is very clearly visible, but you're giving it labels of a traffic scene and it generates the traffic scene, right? So from this segmentation result, you can generate a plausible scene, right? And similarly, you can use it for black and white image to color image conversion, etc. So these generative models, you can use them to get a sample of the distribution, but you can also guide how this thing, what they are doing, right? What images they are generating. So now let's go to diffusion models. Now, diffusion models are trained slightly differently, right? In generative models, if you remember what I just said, there were 2 models that were being trained simultaneously. One was responsible for generating a sample. The other was responsible for checking if the sample looks real, right? And then, they were trained simultaneously and there was this tension between them. And finally, when the things converged, it produced the output. On the other hand, diffusion models, there are two processes going on in a diffusion model. You start with an original image and a small amount of noise is added, right? And in the second step, so here, this is a slightly noisy image. You start with the original image, a small amount of noise is added, and then you add another small amount of noise, another small amount of noise, and so on and so forth. And the goal here is to predict. So given this image, you want to predict the denoised image, right? So you are at each step, you are learning a little bit, you're learning that how do I go from this step to the next step, right? That is in the forward pass, basically in the forward diffusion, you add noise. In the backward learning approach, you try to remove that noise because you already know what the original image was. You try to learn a neural network that tries to remove that noise, right? So this is a fundamentally different approach than GAN, because in GAN, you started with a noise and immediately tried to guess what it was, in one shot. But here, you're learning slowly, iteratively, you're learning how to get this model, right? How to get to the original image. So now you can imagine that you can start with any noise, and then it will create an image of a face if it is trained on faces to create a sample from the distribution, right? Now, GANs, they were very popular. Even now they are very popular. But the problem with GAN is that the training is unstable. And part of the reason for that instability is that they are simultaneously training two models, and also you go from the noise to output in one shot, right? They are kind of tricky to train. On the other hand, diffusion models are more stable. It's basically a single model that you train, and it iteratively at each step, it is learning a very small denoising, right? From a small amount of noise, it's going to a better image, right? So it is iteratively trained. It is slightly better. In the past, there was some memory constraints, diffusion models, because the whole image was the size of the image did not change during this diffusion process. It required a lot of memory, but later on they figured out a way to train the model with much less memory by doing this diffusion in something called a latent space. The details are not important. Now, the thing called stable diffusion is basically a model which doesn't take as much memory as it used to be. So that piece is called stable diffusion, where where we are using the latent space to compress the image, and it doesn't need to the whole image doesn't need to be trained. At the same time, when this was happening in computer vision, we were seeing some very impressive progress in natural language processing. So in natural language processing, the fundamental generative AI problem is the prediction of the next word, sentence, or a paragraph, right? And I'll give you an example. So let's say this, I hope you, right? This is the fundamental problem. And if you actually look at, let's say, Gmail and other tools, they automatically try to predict the next word for you when you're typing, right? And you can use their prediction. Usually they do a pretty good job. But, people can give me an example. What do you think is the next word? I hope you hire me. That is interesting.
Wow, great, really good one. Excellent answer.
Okay, so, yeah, exactly. Jagadish.
Jagadish in the chat got it perfectly, yes.
Yeah, so I hope you're doing well, right? It is a very common expression people use. So, and these predictions were solved using something called RNN, which is recurrent neural networks, and LST, which a variation of it is LSTM, long short-term memory, right? The fundamental problem here is the context. With traditional RNNs, it did not have enough context, right? Of course, if I give you this example, and this is your context, you only know this much, right? You only know this much text. You have looked 3 steps behind you, right? You have three steps behind you. Then you can predict that, oh, I hope you hire me, or I hope you're doing well. But context is very important. How far you can look behind determines how well you can predict, right? I'll give you an example. Now, if I give you more context, suddenly, right, the whole thing changes. Now, we have just changed from 3 words to now 6 words, right? And the entire meaning changes, right? Mm-hmm. Now, imagine how the context will change when you have an entire paragraph, or the whole story, a book that is being written, right? If you don't have the entire context, you cannot go move forward, right? You cannot make the right prediction. And that was the hardest thing in NLP for the longest time. When RNNs came out, they could have some context. With LSTM, it gave you a bigger context, but you were still limited by, still limited. It was not infinite context. So one big thing that happened in NLP was this concept of transformer architecture that allowed for, technically, you can say that it allowed for infinite context, but then you're limited by the GPU memory, etc. But pretty big context, right? And that was a very big revolution in NLP and sequence learning, that you can actually have a very big context so that you can make better predictions, right? Simultaneously, there was another interesting thing that happened, which is called contrastive language image pre-training, or CLIP. Basically, you can imagine that, there was all this innovation happening in natural language processing. There was all this innovation happening in computer vision, but nothing tied them together, right? So it is a very natural thing to think that, the images and text, when we think about all the media in the world, right, all the images, etc., they don't lie in isolation, right? Usually when we take pictures, let's say it's a picture of a dog, right? There is some context, right? There is some text that goes, or language that goes to describe that image. So it's a very natural thing to say that, can we train a very large model on all the images on the internet, right? As much as you can find, and get the context of that image from the text that surrounds the image. Maybe the image has a caption, maybe the image has an alt text, all those things, so that we learn about images without actually having to provide labels, right? So, here is what the architecture of a CLIP looks like. Basically, you have an image. You convert that image, you encode that image. By encoding, it simply means that you represent that image as a vector, right? A vector of numbers. And there are, when you train a neural network, it basically encodes an image into something which is useful for the task it is being trained on. For example, a classification neural network would encode an image so that this encoded image is good for classification task, right? So the image can be encoded, which is a long vector. The text also can be encoded. Any piece of text you have, it can be made into a vector. Now you have two vectors. One is an image and one is text. The basic idea behind CLIP is that because you have these image and text pair, maybe the caption of an image or some surrounding text of an image, you can try to minimize the distance, right? These are two vectors. Let's say they are equal sized vectors. You want to try to minimize the distance between these two vectors, right? And between this vector that represents the image and the vector that represents the corresponding text, you want to minimize that distance, and you want to increase the distance between text which is not corresponding to that image, right? And you can do this because you're taking, randomly sampling. Let's say you have a data of 1 million images, and corresponding to those 1 million images, you also have 1 million text sentences, right? Now you randomly sample, let's say 8 images from it, and the corresponding 8 text. Now the chances of from these 1 million images that 2 of the images are that of a dog, that is small. So you can say that, okay, all these 8 images are different from each other, and I want to make sure that I'm learning so that the weights of the neural network are changing in such a way that the distance between the text vector for the first image and the first text, they match, right? It's close, the distance is small. And the distance between the second image and all other text vectors it is large, right? So that is why it is called, this contrastive learning. You are creating a contrast between similar text and image and dissimilar text and image. So the benefit of this language model and combining language model with vision model or clip is that now you have text corresponding to the image, right? So, and you didn't actually label this thing manually, right? You did not have to go and say that this image is a dog. You just went on the internet and gathered all the data that is possible for various kinds of images, and you also got the text labeling for free. It's not perfect, but when you use it at scale, it produces an image which is very, it produces this connection, which is very powerful. Now, once you have this model, you could give it an image and say, oh, what is the corresponding text for this image? What is the text that best describes this image? On the other hand, you can also give it a text and say, find the image that best describes this text, right? So it goes between images and text in a fluid way. Now what happens is, it's a big revolution because you have combined language models with image generation model, and all kinds of magic happen once you're able to do that transformation. So this class of things started appearing in April 2022. Dali 2, it was a model that was generated by, launched by OpenAI. Basically, you give it some text and it will generate the corresponding image for you. And just a month later, in fact, maybe the same month, ImageGen was released by Google. It does exactly the same thing. Basically, you give it some text and it will give you the corresponding image. By July, Midjourney came up with another Discord chatbot where you can simply type in some text and it created some very artistic image. So Midjourney is very popular. In fact, I was, I think March of July 22, I was talking to David Holtz, who is the founder of Midjourney, and he was explaining me the thing that he was working on. And my question was that, who's going to pay for this? Nobody's going to pay for this, right? And he said, I don't know. And now it's taken off in such a big way, and it's very profitable.
Hey, you can't win them all.
I did not get Twitter also, right? When Twitter first launched, I was like, who's going to use this thing?
Well, but now we've all been proven right by Twitter, I guess, at the end.
But the main thing, the big thing happened with Stable Diffusion by Stability AI, because all these models, 1, 2, 3, they were not open source. And Stable Diffusion model, they made all the weights. The whole, there were two innovations. The first thing was they made it open source, so anybody could go and get the model without paying anything to stability.ai or anybody, right? And the second thing was that this model was tiny compared to, I think in memory, the size of the model was about 8 gigabytes, which is nothing, right? Which means that you can run this model on a consumer GPU, which was not possible. None of these other models, Dali 2, ImageGen, or Midjourney, first of all, you don't have the models with you. You cannot try it yourself. You just have to use their API. But even if you had the model, you would not be able to run it because these things are massive. But Stable Diffusion, this was a tiny model, just 8 gigabytes in memory, which was it just opened up the doors for everybody. Now, there are some interesting things about this Dali. So Dali was, the main author of Dali was Aditya Ramesh. And this guy did not even have a graduate degree. So the reason I'm mentioning this is that a lot of people, watching this webinar may be thinking that, oh, I don't have much experience in this field. It will take me a long time to, contribute anything to the field. But literally, this is Jan Lakan saying about Aditya Ramesh. He says that he has a bachelor from NYU, where Jan Lakan was teaching. And he worked on a couple of research projects, and then he got an internship at OpenAI, and then finally, basically, he came up with the idea of Dali. So think about it, an undergrad is able to contribute. The field is so fresh. The field is so fresh that even an undergrad is able to contribute. And I'm not taking away from all the talent and the hard work that Aditya must have put in, but it is a very new field, which is full of possibilities, right? Another example, Stability AI, the founder is Imad Mustaq, and he was a hedge fund manager. He has a computer science degree and everything, but he comes from a hedge fund background. He just saw that, oh, AI is taking off, let me do some good. He has this philanthropic angle. He wants to, make AI available to countries which are not as prosperous as the United States. And also, he doesn't want these technologies to be controlled by a few companies like Google and Meta, etc. So, but he's a hedge fund manager who comes into this field literally a few months back, maybe a year back, and then he starts funding this, and he's creating something very interesting. Now, this is again astounding that people from many different areas are able to come in, and within a very short period of time, they're able to contribute to the field. So let's go over some of the applications of these new ones. The new areas, they combine text and image, and now it opens up a whole lot of possibilities. The first thing is obvious. The first one is basically image generation, where you type in a prompt. So these images were generated using Stable Diffusion Model by Stability AI. And this is the prompt you gave. You basically type in this text, and it generates these 4 images for you, and you can choose whichever you want. You can change the prompt, and it will create new images for you, right? So this is the basic image generation. And now, like I was saying, that
not just the prompt, right? You can generate infinite images just by changing the seed value itself.
That's true. That's true. That not only this, like if there is a random seed that the algorithm takes, you change the random seed value, let's say from -1, pick some number, right? 42 to 43. And suddenly you have a new set of images that you get, and you can literally experiment with it, change the prompt, change the seed so that you get what you want to generate, right? So this is
it can create infinite images. So it's called infinite image generation machine, right?
Yeah, and you don't need to be an artist. You need to have the imagination to say what you want, right? But you don't. I mean, I could never create that kind of art. And for me to even do this kind of thing, it is mind-blowing, right? It is very empowering in some sense. So yeah, that's the basic thing that you can do with these models. But you can also do more sophisticated things. Here we are showing an example of in painting. There is a microphone. If you look carefully, there is a microphone, and that is being masked. We are saying that, okay, remove this microphone. And it is removing the microphone, and you can see that the microphone is gone in the next shot. This thing is called in painting because you are painting inside the image. But you can also do something called out painting. So this is a image. This is a photo I took in my recent trip to Hawaii, and the image is vertical. You can see that and we have made it a square image by out painting. We are adding to the image outside so that it finishes. So in the original image, you can see that the palm tree is not complete. By using Stable Diffusion Model, we are able to do this completion called out painting. You can also do all kinds of virtual try-on, virtual clothing. You can put a hat on the person. You can add glasses just by writing a few lines, prompts, right? You can change the color, add buttons, God knows what, right? All
but
kinds.
Can you put a hat on a hat?
That's you can try.
Yeah, you just have to do it twice.
I'm just asking for my Team Fortress 2 people. The 3 people in the audience that get that will think it's hilarious.
Similarly, you can see here is an example of a virtual try-on. The bow is changing, the hat is changing, and the color of the coat is changing. Fascinating stuff. Fascinating stuff. It is mind-blowing. It looks like science fiction even to me, who has been in this industry for the last 20 years. It is mind-blowing.
Yeah, and I mean, you've even actually have direct experience working on virtual try-on tech too.
Yes, in fact, we'll come to it. Virtual hair is another one. You can use this technology to create various hairstyles. Virtual makeover. This, my first company was actually doing virtual makeover. Women could upload their own picture and apply makeup virtually. Now, to create that, we had to have this detailed facial landmark detection model, and then we had to have rendering algorithms for every piece. For example, lipstick, we had a lipstick algorithm, we had an eyeshadow algorithm, we had a segmentation model for segmenting hairs, etc. All this was very complicated, right? It took us many months to, a team of 5-6 people, many months to create this solution. But now you don't need segmentation. You don't need, because the model is already trained, you don't need detailed things like that. And you can simply create a virtual makeover application with literally one person working on it for some time. This is an example of virtual aging. By the way, all the examples that we are showing here, these will be covered in our Kickstarter campaign course, which I'm going to talk about next. So here,
it looks like somebody found the painting in Tom Cruise's attic.
So we will also show you how to fine tune a model. So here, these are real images of me. So we took about 20 images of me and fine tuned the stable diffusion model. Now there is a person called Satya Mallick in the model. And if you say that I want Satya Mallick in a particular costume, we can generate that. And here are some examples. The left one is me in a cricket outfit, then in football, and then soccer, right?
I still say the cricket, Satya, you should try the earring. It looks good on you.
Yeah, there is an earring. If I blow up the image, you can see that there is an earring in that image. But it looks very plausible. It looks very nice, right? And you can keep improving this by adding more images of me in the model, or when new models are released. Right now, there is only one open source model available, but new models, I'm pretty certain that a lot of companies will open source their models. So this is fascinating stuff. I mean, this is science fiction. All this thing was generated by training, fine-tuning the stable diffusion model, which takes about 20 minutes or so using the right technology. And once you do that, you can simply write prompts to create all these images, right? Just mind-boggling. Here's another example of me receiving the Oscars.
I like traveling musician Satya with the sitar there. It's pretty sick.
That's right. That funny instrument, whatever it is.
It looks like a sitar to me. I think it's a sitar.
Oh no, sitars are a sitar is much bigger.
They make electric sitars, my friend.
Oh, I see. But this is just science fiction. I'm so excited about this thing. I can't believe these things can be done so easily, right? It's really interesting stuff. Here's portrait animation. This will also be covered in the course. Some portrait animation, we got you covered. You can create that by just typing a few words. Astonishing, right? So basically, you can take your photo, you can have a guiding image or a guiding video, which will animate other images, right? This was not a bunch of images that were taken. A single image was animated. Again, if you ask me, it is all science fiction to me. So a little bit about our Kickstarter campaign. We are, as you know, that we launched a Kickstarter campaign a couple of days back, and we crossed 70,000 in total. More than 800 backers have backed this. And it's basically a Kickstarter campaign for 2 courses. The first one is AI art generation for everyone. This is for artists and it is for artists and people who do not know any programming. So we will teach them all the tools that are available for or that are popular in this domain that will allow you to do all the things that I already mentioned before. And the second course is for advanced AI art generation. For this, you will need some coding experience, and I'm guessing that most of the people who are watching this webinar have some programming experience, right? You don't need to be an Uber programmer as Elon Musk's hardcore programmer. You just need to know, you just need to be able to run Python code, Jupyter notebooks and such, right? And that's enough. So here we will teach you how to fine tune a model. We will teach you how to use how to actually do prompt engineering also. So it depends how well the results are produced. It depends on how well you ask the AI model and what are the keywords you use to ask. But we can automate that piece also by training a GPT model based on a collection of prompts, right? We take a collection of very good prompts, and then we train a GPT model, which will help us create the nice prompts. So even that piece can be automated. So
that's awesome. Quick question from the peanut gallery here. How long will each of these courses take to complete on average for the folks that?
So these are very short courses. Each of these courses would be 1 weekend, right? So let's say, 1 weekend and let's say 20 hours, right? If you spend 20 hours on this, and half of it would be spent on the material, the other half would be spent on experimenting with various things, right? And this is all fun, right? You won't even notice the 20 hours. So
it's going to be binge watchable, right?
Yeah. It would be
not just binge watchable, but binge learning.
Right. So we actually, we recommend, because most of the people here are programmers, they should just buy the bundle, which is for $69 during this campaign. And it will give you both the courses, and, we'll keep adding some stretch goals to the campaign. And this thing is going to be very, very interesting. During this campaign, we are also selling all our courses. There's a package where you can buy all our courses, including these new courses, for $997. So this is the Super Master Bundle. If you've been on the fence for, waiting for a good deal on our courses, this is the time. Go and check it out. It's a pretty good deal. I don't think we have had this this pricing even during the holidays. This is a pretty sweet price.
Yeah, and that includes not just this new course, but also the courses that are available on opencv.org/courses today, including Computer Vision 1, Deep Learning with TensorFlow and Keras, Deep Learning with PyTorch, and the one of the more recent ones like OpenCV for Beginners and Computer Vision 2. Are they all in that bundle?
Everything is included in the bundle.
Wow, that is a crazy deal.
That's a very good deal. Yeah. So, just to give you an idea of what you will learn the fundamentals of AI art generation, get a strong understanding of the basics. I covered some of it, but it's not obviously in 1 hour. I cannot cover a lot, but you will learn the tools and techniques. It's a very practical course, and things are moving so fast. We want to make sure that you know the right tools and right techniques. For example, you could use you can use some prompts to create one image, but let's say you want to change the image. Simple things like you want to change the direction of the head. I want a profile picture or something like that. It may not be feasible easily to just use a prompt. Sometimes you may want to use an image to guide the prompt, and those things, there are a bunch of parameters. If you look at some of these tools, there are a bunch of parameters. If you are a complete beginner, you will not understand what those mean and how they function. So you will understand, once you take the course, you will understand all the various parameters that you can tweak to get the image that you want to create. The second thing is we'll also talk about prompt engineering, which is how to tell the AI to make the art that you want. And there are a lot of subtleties in these AI models. So we will learn all of that. We will learn how to fine tune the model, as I had mentioned before, so that you can create your own styles. You can create your, you can add new objects to your model. And then we'll talk about, we'll learn about image editing, how you can control the editing process and create things like virtual try-on app, virtual interior designing. You can also put things inside a room, for example, to create a virtual experience. We will teach portrait animation, and we will also build our own models, right? So in terms of models, we will go over Stable Diffusion, Midjourney, and Dali 2. Of course, with Midjourney and Dali 2, we do not have access to the model itself. So we will teach you, how to use these APIs and interfaces to create the right image. But with Stable Diffusion, we will go much further because we can actually modify the model, etc. The tools that you will learn, Dream Studio, there is another one called Automatic 1111, Hugging Face, Lexica, Playground AI has a new tool. There are some models available in Civit AI, which we will cover. So it's going to be a great learning experience. We will cover a lot of things, but we'll also keep the course short so that you can quickly learn it. And the courses will be launched on the 1st of May. Yeah, that's pretty much it.
Yeah, please go on Kickstarter, back this awesome campaign. Get yourself the best prices I think we've ever had on OpenCV courses, and this is definitely our most affordable course ever. This new Mastering AI Art Generation. So yeah, help us out. Spread the word. Do a tweet. Post it on Facebook. Send a newsletter. The more people that get out there too, the more likely it is we can do stuff like this in the future at these very reasonable prices.
Thank you. Yeah, and we are ready to take some questions. Should we?
Yeah, definitely. Let's do a giveaway here. Thanks everybody for thanks everybody for sticking around. We're a little bit long this week, but when things are so cool, it takes a little bit longer to go through them sometimes. So if you're joining us for the first time, or you just need a little reminder, one of the things we do every single week here on OpenCV Weekly Webinar is give away something to you in the audience. This week, we'll be giving away one OpenCV course for Mastering AI Art Generation, which will launch on, I believe you said May 1st. Was that the?
Yeah.
Awesome. The way this works is you're going to answer the question I ask in the Zoom chat. If you're not in Zoom, you can go to opencv.live and get in there. You've got about 10 seconds. I'm going to ask you a question based on the presentation earlier today. If you have won in the last 2 months, please don't answer and give someone else a chance to win. Get ready to answer now. Earlier in the presentation, we discussed the launch times of some of these really popular frameworks like Stable Diffusion and Dali and ImageGen. What month and year did both Dali 2 and Google ImageGen launch? Oof. Okay. Thomas just like boom. It's tough to gosh and golly. I think Thomas Sheratel was our first one there. April. The correct answer we're looking for is April 2022. Also super quick on the draw was Christian. Sorry, you were just a little bit too late. And Sujesh was in there. But good luck next time. Congratulations to Thomas. Thomas, please send one email to phil@opencv.org, and we'll make sure that you get the course when it launches.
So Christian might have missed it by maybe a fraction of a second, but I think he has already bought the course. So
thanks, Christian. We appreciate it. Yes, we've got a ton of questions here this week. We'll do a couple before we drop off today. Let's see here. There's quite a few. So somebody asked one that's a little less complicated, a little less technical and more personal. I'll ask Satya and Vikas both. Satya, you first. Which of these models that you've used recently, Stable Diffusion, Dali, etc., which of you like personally think you've had the most fun with, or have you noticed any like differences between their outputs over time because you've used them so much?
So the first one, Dali 2 was the first one, and right after that, ImageGen came out. So ImageGen is they claimed in the paper that it is slightly better than Dali 2 on various tasks, which they are coming in later, a few days later. So obviously they try to make it better. Midjourney is very popular among artists kind of people because they are all trained on slightly different data sets. So, depending on what your, what flavor you want, Midjourney is very popular among artists. And finally, Stable Diffusion is the open source one. So we like it the most, right? Because you can do stuff with it. With others, you're limited by what the API provides, right? You can do some prompt engineering and other things, but you cannot add new things, right, easily to these models. Not easily. You cannot add
like
models
at all in many cases, right? Yeah, except for Stable Diffusion. That
unless they provide some API to do that. But Stable Diffusion, you have full control. They have pretty much released the model, and people are building. Not only that, they have released the models, but people are also building on top of it. For example, at civet.ai, you can download some models where you can have new costumes and you can have new characters, etc. Be a little bit careful. Some of these models are not safe for work. So if you
yes, there's I mean, sometimes the things they generate are completely benign but are still not safe for work. There's been a photo of a starfish going around getting banned on Facebook all week, so it's a real thing. Look it up.
okay.
Vikas, what's your opinions on the various ones? I know you've got a ton of experience using these, especially over the last many months. What are your thoughts on how they compare to each other in terms of, have you noticed any like interesting differences in the outputs that you personally kind of attach to?
Yeah, so basically Dali 2, the results that you get is like, it's very consistent, and it's easier to use because they have a very nice API as compared to, say, Midjourney, which requires you to log into a Discord channel and use Discord messages to generate images. But the good thing about Midjourney is that it is very well trained. So you can generate very good images without a lot of prompt engineering. So the outputs that you get from Midjourney are really good. And earlier it was like, it was very common among artists because it used to generate artistic kind of outputs. But now with their latest models, it has become very realistic also. So you can generate pretty much any kind of output. I mean, it was very recently released, I think maybe 1 or 2 weeks back. And since then it has been all rage around the open source and around the creator community. And coming to Stable Diffusion, obviously it is open source, and because of it being open source, there are so many applications being created, right? So that is basically giving it wings, right? So basically that is a gist of about these three models. Imagen is basically closed source, so you cannot do much using Imagen. But Dali 2 Midjourney is really powerful. You don't have to, I mean, for non-technical people, Midjourney is probably the best option. And if you only are looking for artistic kind of images, and if you really want to dig deep and do whatever you want, whatever you can imagine, then Stable Diffusion is the way to go.
That's good advice out there, folks.
Applications people have built, the application that I showed you where, my photo with various outfits.
Yep.
There's an application, there's an app on on the App Store, iPhone App Store called Lensa.
Hmm.
And they charge you $8 to create 200 of those images, right? And I paid for that. I don't know whether it's still true. There were rumors that at some point they were making $2 million a day with that.
Apparently, it's been a pretty precipitous drop. There, it's like 10% of the usage it was a month ago.
Doesn't matter, right?
But
You run this for a few.
Yeah, no, I mean it's
few days and then you retire.
It's a gold rush. Yeah, it's exactly. It's a gold rush. You don't. It's not about longevity. It's about getting the most gold out of the river right now.
Right.
Yeah, that makes a lot of sense.
This lasted for only 30 days, made $60 million. Now I have retired, right?
Yeah, like, oh gosh, if only it would have lasted another month, I could have retired 3 people. Yeah, I mean, we're pushing 15 past the hour. I think we should probably call it a show. Thanks so much, everybody, for joining us. Satya, you want to take us home?
Yeah, thank you so much for this, joining us for this presentation. Really thankful, and I'm pretty certain that a lot of you have supported us in the Kickstarter campaign as well. So I want to thank all our backers. It is because of you that we are able to even dream of reducing the price so much. We know that a lot of backers would help us so that we can make it up in volume.
Yeah, thanks to all 826 of you so far.
That's a very big number. And I also want to thank Vikas, and I wanted to have him on the show because he's the course director. He puts the course together, and the community should know about his contributions, which he's been doing an excellent job. So thank you, Vikas. And if you have any questions, please send us an email at courses@opencv.org. And I hope you support us during this Kickstarter campaign.
Yeah, thanks again for joining us, Vikas. Our guests next week will be telling us more about the Intel Dev Cloud for the Edge. We'll be talking a little bit about training and deploying stuff using that with some of the new Intel hardware that's out there. So join us for that. Same bat time, same bat channel, 9 a.m. Thursday. Also, if you're bored this weekend, Saturday night, I'm running a movie night on my side project, Retro Strange. That's retrostrange.com. We'll be watching a couple of 1950s hot rod movies. It's going to be fun. I hope to see you there.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.